Well, student, today I am going to tell you about isomerism in coordination compound. In this video, I will focus mainly on geometrical isomerism and optical isomerism. So, to learn about geometrical isomerism and optical isomerism, please stay tuned with me till the end of this video. And if you are benefited from my video, then don't forget to like my video, share my video, and please do subscribe my channel. Let's start with our topic isomerism. So what is meant by isomer? Compounds having same molecular formula but different physical and chemical properties are called isomer. Compound having same molecular formula but different physical and chemical properties are called isomer. And the phenomenon of existence of such compound are called isomerism. Now this isomerism is broadly categorized into two classes. One is structural isomerism and the second one is stereoisomerism. So isomerism is broadly categorized into two parts, structural isomerism and stereoisomerism. Now under structural isomerism there are four subdivisions. The first one is ionization isomerism. The second one, linkage isomerism. The third one, coordinate isomerism. And the fourth one is solvent isomerism. Now under stereoisomerism there are two topics or two subdivisions. The first one is geometrical isomerism. And the second one is optical isomerism. So under structural isomerism we have four topics: ionization isomerism, linkage isomerism, coordinate isomerism, solvent isomerism. Under stereoisomerism we have geometrical isomerism and optical isomerism. Now I will discuss about geometrical isomerism. So what is geometrical isomerism? Now before going into geometrical isomerism, we should know what is meant by stereoisomerism and what is meant by geometrical isomerism. Now stereoisomerism means compound having same molecular formula, same sequence of bonding but different spatial arrangement. Compound having same molecular formula, same sequence of bonding but different spatial arrangement are called stereoisomer. Now under stereoisomer there is geometrical isomerism. Now this geometrical isomerism is defined as compound having same molecular formula, same sequence of bonding but different relative arrangement of atoms or ligands. Compound having same molecular formula, same sequence of bonding but different relative arrangement of atoms or ligands. Now this geometrical isomerism, we will start our discussion with coordination number. So the first coordination number is coordination number 4. Now under coordination number 4, two types of structure are possible. As we know, coordination number 4, the structure can be tetrahedral or it can be square planar. Now in tetrahedral, the metal is surrounded by ligand and the bond angle is 109 degree 28 minutes. So here one ligand is apart from another ligand by an angle of 109 degree 28 minute. This ligand is apart from this ligand by 109 degree 28 minute. Here all the ligands are 109 degree 28 minute apart from each other. That means the relative arrangement of ligand are same. Hence tetrahedral geometry will not have any geometrical isomerism. In the other case, the square planar geometry, the metal is surrounded by 4 ligands. Now if you consider the ligand 1, ligand 2, ligand 3, ligand 4. Now the angle between ligand 1 and ligand 2 is 90 degree. The angle between ligand 1 and ligand 3 is 180 degree. So the relative arrangement of the ligand are not same and hence they can show geometrical isomerism. Now in case of a square planar geometry, they show only 2 types of isomerism, that is cis and trans isomerism. Cis isomerism and trans isomerism. So under coordination number 4, we have seen that square planar geometry can have geometrical isomerism, and that is cis-trans isomerism. For example, the first type is MA2B2 type. MA2B2 type means in CBSE often the question arises PT NH3 whole 2 Cl2. Draw the isomer of PT NH3 whole 2 Cl2. Now this PT NH3 whole 2 Cl2 will have 2 isomers, cis and trans. Cl, Cl, NH3, NH3. Now when both the chlorine atom is on the same side, both the ammonium ligand on the same side, it is called cis isomer. If same ligand are diagonally opposite, then we call it trans isomer. When same ligand are diagonally opposite, then it is called trans isomer, and this one is called cis isomer. This cis isomer is called cisplatin and it is a anti-cancer agent. Our second type is MABCD. So often in the entrance exam like JEE Mains and NEET, you will find question how many geometrical isomer are possible for MABCD type of complex. Now how to find out the number of geometrical isomer? The easy way to find out the number of geometrical isomer is keep the ligand A fixed. With respect to A, keep B at trans position. Keep the ligand A fixed. Keep the C ligand at trans position. Keep A ligand fixed. Keep D ligand at trans position. So keeping A fixed, you can keep B at trans, C at trans, D at trans. So a maximum of 3 geometrical isomer is possible. Now I will show you the structure of the 3 geometrical isomer with example. PT, NH3, pyridine, Cl, Br. This is one complex where all the 4 ligands are different. So it will have 3 geometrical isomers. So we will keep the first ligand NH3 fixed. With respect to NH3, we will keep the second ligand at trans position. Cl, Br we will put arbitrarily. Now the second structure, keep the NH3 ligand fixed and the C ligand, that is chlorine, at trans position. Put the other ligand arbitrarily. Now the third one, keep the NH3 group fixed. Put the D ligand, that is Br, at trans position and put the other ligand arbitrarily. So you will get a maximum of 3 geometrical isomers. Next I will discuss the geometrical isomer under the coordination number 6. So when coordination number Cn is equal to 6, the only structure possible is octahedral. Now in CBSE board exam, there are only 3 type of compound which shows geometrical isomerism, and by studying only that 3 type you can score full marks. The first type is MA4B2 type. The second type is MAA whole 2 B2. This AA means it is a bidentate ligand, for example ethylene diamine or oxalate ion. The third one is MA3B3. So we will start our discussion with the first one, MA4B2. MA4B2 example is CO NH3 whole 4 Cl2 whole positive. Now this compound can exist in 2 forms, one cis, another trans. When the 2 chlorine are diagonally opposite, it is the trans form. Put the ammonia, when both the chlorine are taking adjacent position, it is the cis isomer. So we have only 2 isomers, trans and cis. So MA4B2 type complex will have only 2 geometrical isomers, that is one cis, another trans. Next we will move on to the second type of compound, MAA whole 2 B2. Now this MAA whole 2 B2 type compound is CO En whole 2 Cl2 plus. Now this also can have only 2 isomers, one cis, another trans. So first we will draw the trans one because that one is the easy one to draw. Cobalt, put the 2 chlorine atom above and below. So you will get the trans isomer. Now you have to put the En, that is ethylene diamine or ethane 1,2-diamine. So you write En and you will join like this. Since it is a bidentate ligand, you will join 2 center. The cis one, CO, again the easy way is to keep the 2 chlorine adjacent and then put the En. So this one is cis. Next we will move on to our third example, that is MA3B3 type. The next type is MA3B3 type. Now under MA3B3 type, the example is CO NH3 whole thrice NO2 whole thrice. Now this compound also has 2 geometrical isomers, but here it is different from cis trans. NH3, 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 NO2, NO2, NO2. Now you have to put the ligand in such a way so that if you join the same ligand, you will get a triangular face. If you join the ligand, you will get a triangular face. Here also, if you join the same ligand, you will get a triangular face here. So this type of isomer is called facial isomer. Facial in short, FAC. There is one more isomer, CO. Now keep the same ligand in the square plane. NH3, NH3, NH3. So we are keeping all the same ligand in the square plane. Now put the other ligand, NO2, in the empty space. Now when all the same ligand are in the square plane, this type of complex is called, or this type of geometry is called meridional, or in short it is MAR. Meridional, or in short it is MAR. Next I will discuss optical isomerism. Now what is meant by optical isomer? Compound which can rotate the plane of plane polarized light either to the right or to the left are called optically active compound. If it rotates to the right, we call it dextrorotatory. If it rotates to the left, we call it levorotatory. So once again I am telling you, what is optical isomer? Compound which can rotate the plane of plane polarized light either to the right or to the left, then it is called optically active. If it rotates the light in the right, then it is called dextrorotatory. If in the left, it is called levorotatory. Now again we will start our analysis with the coordination number. The first coordination number is Cn equal to 4. Again with Cn equal to 4, we have two structure possible. One is tetrahedral, another is square planar. Now in case of tetrahedral geometry, if the metal is bonded to 4 different ligands A, B, C, D. Here in square planar also, the metal is bonded to A, B, C, D. Now in case of tetrahedral geometry, the metal is bonded to 4 different ligands, and so this compound is optically active since it does not contain any plane of symmetry or center of symmetry. It does not have any plane of symmetry or center of symmetry. Now this compound, square planar compound, this square planar compound is just like this mobile phone. Now the 4 ligands are present at the 4 corners. Now if you want to slice it, then the 4 ligand will get sliced into 2 equal half, and that means you are passing a plane through the molecule which divide the molecule into 2 equal half. And whenever a plane divide a molecule into 2 equal half, we call it plane of symmetry. So this molecule contain a plane of symmetry, and that plane is the molecular plane. So this will be optically inactive due to molecular plane of symmetry. It is optically inactive due to molecular plane of symmetry. Next, I will discuss the optical isomer of compound with coordination number 6. Coordination number 6, and we know with coordination number 6 the geometry is octahedral, and we have seen in the geometrical isomer of the type MA4B2, and the second type is MAA whole 2 B2. Here there is a new type, that is MAA whole 3. So these two compounds we are familiar with. This is a new one. So let's start with the first one, MA4B2. MA4B2, the compound CONH3 whole 4 Cl2, and this compound can exist in two geometrical isomer, that is cis and trans. So let us draw the cis isomer first. Chlorine, chlorine, NH3, 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 NH3. Now this one is the cis isomer, and the trans isomer is this. Keeping the two chlorine above and below, you will get the trans isomer. So in case of trans isomer, you can see the 4 ammonium ligand are in the square plane, and the 2 chlorine is one above and one below. Now if you slice the entire molecule, then you will find that the chlorine above chlorine and the below chlorine, the molecule can be divided into two equal half, and so this trans isomer has a plane of symmetry, and hence trans is optically inactive. So the trans one is optically inactive. But in case of cis, what happened? Cis, again, it is optically inactive. Why cis is optically inactive? See, the chlorine atom, one is above, another one is at this corner. One above, at this corner is another atom, and the rest 3 corner is ammonium ligand, and below there is another ammonium ligand. Now if we slice the molecule like this, a diagonal plane to the square base, if you slice it, then what will happen? Then this ammonium ion and this ammonium ion, you can slice it into two equal half. This ammonium ion and this above chlorine will get into two equal half. So this compound will also have a plane of symmetry, and hence it is also optically inactive. So we have seen that MA4B2 is optically inactive, whether it is the cis isomer or the trans isomer. So we will move on to the next one, that is MAA whole 2 B2. Now this MAA whole 2 B2 type compound is COEN whole 2 Cl2 plus. COEN whole 2 Cl2 plus. Now we will first draw the cis isomer. CO 2 chlorine, En now the cis isomer is optically active because you cannot cut the molecule into two equal halves. There is no symmetry plane. If you put a diagonal plane like this, then you will get the chlorine atom sliced into two equal halves, but the lower En group will not have a equivalent group on the other side, because this En is in the surface and this En is below. So this is optically active. This is optically active because it does not contain any symmetry plane. Now the trans one, this one is the cis one. CO, Cl, Cl, En, En. Now as you can see, you can slice the molecule like this, and so one half of the molecule is the mirror image of the other half, and so this is optically inactive due to presence of symmetry plane. Optically inactive. Now whenever a molecule is optically active, it can exist in two optical isomers. One is dextrorotatory, another is levorotatory. And this dextro and levorotatory, they are defined as enantiomer. What are enantiomer? They are optical isomer which can rotate the plane of plane polarized light to the same extent but in opposite direction. So we will draw the enantiomer of this optically active compound. So put a mirror plane. Now the mirror image of this compound, enantiomer are optical isomer which are non-superimposable mirror image of each other and which rotate the plane polarized light to the same extent but in opposite direction. That means it is non-superimposable mirror image. So we have to draw the non-superimposable mirror image. Cl, Cl, En, En. This En will have reflection here. This En, the reflection will be here. This chlorine, reflection here. This chlorine, reflection here. And this En, it is at the back, so its reflection will be here. So whenever in board exam you will get this question, draw the enantiomer of the compound COEN2Cl2. Then you will draw first the geometrical isomer. You will state that the cis isomer is optically active, whereas the trans isomer is optically inactive due to presence of symmetry plane. And then with the cis isomer you will draw the two enantiomer. Then only we will get the full marks. Next we will move on to the third type, MAA whole thrice. This is our last molecule, MAA whole thrice. Now this MAA whole thrice, it is of the type COEN whole thrice 3 plus or COOX whole thrice 3 minus. Now this MAA whole thrice, it does not have any geometrical isomer, it has only optical isomer. That means the molecule can exist either in dextrorotatory form or in levorotatory form. So we will draw the structure and we will write down we will draw the enantiomer also. CO, En, En, En. The mirror plane, En, En, En. So like this you can draw the optical isomer of COEN whole thrice or COOX whole thrice 3 minus. So hope you understood all this isomerism, geometrical isomerism and optical isomerism. And if you get benefited from this video, please like my video, share my video and please do subscribe my channel.